All right, should be set. All right, so we're doing how can we integrate the natural exponential function? Natural exponential function being this, e, basically. How can we integrate e? All right. You have this in your notes. So this was actually in your video notes last time you were here. It was just saying derivative of e to the x is e to the x. And we did some practice problems like that. We did some stations like that. We also said on those notes, you don't have to write this down again, but the derivative of e to the u was u prime e to the u. Remember, we just bring the u prime out front. We'd write e to the u all over again. This will still be used a little bit today. This is actually the new piece that I want to get you guys is working in reverse. The integral of e to the u du is e to the u plus c. Okay, so it's basically taking what's up top and then working in reverse. Okay, and this makes sense, right? Because this u prime is really the same thing as du, all right? So this is just taking this and going in the opposite direction. Okay, all right, so I think I have 2 or 3 practice problems, or nope, just to get in your notes, and then you guys practice a little bit on your own. All right, so just got to be really careful on this stuff because especially the last couple of class periods, we've been going back and forth between derivatives and integrals, derivatives and integrals. Now we're back to integrals. So I know it's easy to look at this and say, oh, yeah, like product rule, right? Product rule is only for derivatives. So only thing we can really do at this point for integrals is u substitution. We have this formula, e to the u, right? Especially when you start working on that worksheet that I'm going to get you guys, there's going to be a lot of questions as to like what you should set your u equal to. And most of the time, if you just look at the exponent of your e, that'll work out. It doesn't work every time, but if you just try that to start with, a lot of times that'll get you places. So let's set my u equal to negative x squared. Now remember, the goal is my du should be some form of 5x dx. I might have to manipulate it a little bit, but let's see where it takes us. So let's say du is equal to negative 2x dx. And I don't want -2, I want 5. So let's get rid of that. Let's divide out that -2 on both sides. So now you'll have -1/2 du is equal to x dx. And that's just going to get us one step closer. So if I multiply that by 5 on both sides, that'll get me to 5x dx. That's what I want. Okay, so if I rewrite this, this would be the integral of, it'd be -5/2. Let's pull that out front. -5/2 u du. Okay. And then at that point, you're just integrating. So I'm going to keep the -5/2 right here. This would be u to the second over 2 plus c. This is multiplying. So this would be -5u squared over 4 plus c. And then at the very end, just want to make sure I plug back in my u. So then we have -5. This would be -x squared over 4 plus c. Okay, I did something wrong here. Did I skip a step? Oh, I was going to say, I know I did something wrong. So I forgot my e right here. I just wrote u. You guys catch that? Was anyone catching that at all? Okay, so instead of writing u, I forgot to write my e right here. Do you guys see what I'm saying there? Okay, so let me back up. I knew, like, as I was getting close to the end here, I was like, wow, that doesn't look familiar. Sorry about that, guys. There we go. So this will be not u, it will be e to the u, du. Anything else? Yep, should be good now. Okay, this will make a lot more sense. So now we can use this formula, right? Integral of e to the u is equal to, I'm going to keep my -5/2 right here. And this is going to be e to the u plus c. And then I can plug in my, u. So this would be e to the -x squared plus c. All right, and at the very end though, because remember, we don't want negative exponents in our answer, so let's bring that in the denominator. So my final answer would end up being -5 over 2e to the x squared plus c. Okay, let's try a couple more. Let's see if I don't screw these up again. All right, let's try one with trig. Do one with trig, and I think I have one more after this. Okay, again, when all else fails, just start with setting your exponent equal to your u and see if that takes you anywhere. So I'm going to say u is equal to cosine x. Okay, the derivative of cosine, so du is going to be negative sine x dx. And let's divide out that negative. So I'll actually have negative u, or negative du is equal to sine x dx. All right, so we should be covered. Just got to rewrite it. This will be, I'm going to pull my negative out front. And this would be e to the u du. Okay, and I'm going to keep my negative. I'm just going to keep, so integral e to the u is still e to the u plus c. And then I can just plug in my, whatever my u is. Would be your final answer. All right, last one. You guys will be able to move around a little bit. Let's try one with a definite integral. So this time we're going to have boundaries. Okay. All right. This one, I just have an x as my exponent, right? So probably setting my u equal to my x isn't going to work. Like even if I tried to do that, obviously don't do this, but right, that's not really going to get us anywhere. That's not going to cover like everything that we have going on over here. So that's where you kind of have to back up and say, okay, what else can I do? If I try u substitution, if I'm not setting my exponent equal to u, let's try setting my denominator equal to u. So I'd say u is equal to 1 plus e to the x. That's always a safe bet, setting your denominator equal to u. And then let's say du then would be equal to, derivative would just be e to the x dx. And that works, right? Because that's what's left over right here. Okay. Rewriting it though, we're going to have to change our boundaries again if we're going to leave it in terms of u. So let's write a new lower and upper boundary. So I'm going to write lower over here. And again, remember, just take your old lower boundary and plug it in for your u. So this would be 1 plus e to the 0. What is anything raised to the 0? 1. Good. So 1 plus 1 is 2. Okay, let's write a new upper boundary. So this would be 1 plus e to the first. So e is just an irrational number, right? The decimals just go on forever. So we don't want to do any rounding. Let's leave this as an exact answer. So I'm going to leave my upper limit as 1 plus e. Okay, I'll show you how that works in a second. So I'm going to rewrite. So my lower boundary was 2. My upper boundary was 1 plus e. And what else do we have? It looks like just 1 over u du. All right. This right here just goes back to, again, last class period or the one before that, where we said like the integral of 1 over u is natural log of u. So I'd write natural log, actually with the absolute value symbol, so natural log, absolute value of u, and we'd evaluate it from 2 to 1 plus e. All right. I know it's going to look a little strange, but we're still going to be plugging in these boundaries. So I'm going to say this is equal to natural log absolute value 1 plus e minus natural log absolute value of 2 okay. If it was a multiple choice like AP question, they may leave it like this. They may also go like this. If they compress it even more, they could go like this, right? Because subtraction compresses to division when you're doing natural logs. No, if you're going to compress it, you would get rid of the absolute value symbol. So actually, yeah, like either one of these would be acceptable. Okay. Any questions? Okay. Where did that sheet is? All right, I just want to give you some practice time on this. This sheet, let me get this out to you first, because some of these problems really make you think, and I just want to talk about it really quick. Those of you at home, I'm passing out the extra practice worksheet for integrals with E. Should be up there on Canvas, the first couple links. And Julia, do you want one? You got one, okay. All right, let me stop my record here.